Good morning, students. In this lecture, we are going to discuss about the pointers in C language. Right. What is a pointer? Pointer is a variable. Pointer is also a variable. See that. Pointer is also a variable. Pointer is also a variable that stores the memory address of another variable. Right. Here you see this one. This is one memory location. Memory location where memory location where we are storing the one integer. If you assume that one, right? Suppose we are storing one integer x is some value 40, right? So that is the statement is the end x equal to 40, right? Now we are declaring that another one, a pointer of type integer, right? So that is how do you declare the pointer type of integer is integer star p. Now, if you are declaring that one with that star operator, right, then the star is here, we are having address. So, it's a pointer, right? So now if you are having that in front of while declaring one variable with in front of that one, we are having a star. Now you consider it as a pointer. So pointer is nothing but another memory location where it will allow to store only the address of another variable of type integer, right? So now you are having the dx. Now I am having the statement is p equal to ampersand x. Ampersand x is nothing but address of the x. So this is a memory location where we are having the address for the x. So this is the ampersand of x. Then the ampersand of x is here we are going to store here. Here store the address, right? Then using that address, then we can access the data, right? So if you are printing that variable value x, now we are having percentage d, and you have to use that indirection operator, and you put p. Now it will print the value 40. This is a simple one, right? So we are having that integer type pointer. So the pointer is a variable where we can store the address of another variable. A pointer is a variable that store the memory address of another variable. So another variable here x, here p is the pointer. We are storing the address of the x. P equal to ampersand x. So we can store that address. So you are while declaring that one. So the data type followed by we are space, and then we are having a star, and then you have to give the pointer name. So this is the point integer type and one space, and followed by we are giving now the operator, right? So this is a star. Star is the address, and then we are star is representing the pointer. Then we are having now the pointer name, right? This is the case, right? Now you see the simple statement, right? So integer a equal to 10, integer a equal to 10, integer a equal to 10 is declaring that variable. So a is one location where we are having storing that value 10. So this is one memory location we are storing now, right? So for that we are having one address, right? Now we are declaring a pointer. So this also is another location where we are having now another location. Here you are assigning that one address of that a. So this address of that a is going to be stored here, right? Then here now you see this one. So the a is a value, ampersand a is the address of value. The address of value is a hexadecimal number. So this address is here. This is some 0x the hexadecimal 7f of e 5p f of 56c. So it's long. So you 1 terabyte. Then we are having this long address for the particular location, and then p is also stored in another location. This also stored in another location. It's not in this one. So we are having now some another location, right? So by c something f or something here. Okay, where we are storing now. So now star P is the value at the address. So the address is here P. So value at the address is we are having now 10. It will show now. This is a basic. And then here we are having now. So initially you are declaring a pointer with null means we are having a pointer declared, but here we are having the null. Null is not, it won't null is nothing is there, right? So the no address is placed in P. Just we are declaring a pointer, right? So that is null. And then we are having ampersand x. Then if you, now you are assigning the address. So that x is we are having create another x. Then in that x we are having 5. Now the address of the dx is going to be loaded here. The null is clear and we are having address of x is placed now. Right? So null is nothing but a null pointer. Null pointer is the pointer is not denoting any variable. Not denoting any variable. Just we are having a pointer. It's not denoting any variable. That is null. It's not showing any variable currently. That means we are having a null pointer. Right. Now this ampersand is address of operator. Star is value at operator. Value at operator. Right. Now we already explain about the array. So we are declaring one array of integer. The array of integer is having the 10, 20 and 30 is consecutive memory location, right? So this is one unit of for integer, then another unit for integer. So this is a of 0, this is a of 1, this is a of 2, right? We are initializing that with the corresponding value. Now if you are declaring it that only the array name, this is denoting, this is equal to actually P equal to ampersand A of 0. So first element is representing the first element. Now here P is representing the first element. So star P is giving the first location value. 10 is going to be displayed. Right? 10 is going to be displayed. Next, here we are having a 10 is going to be displayed. Then here, if you are incrementing by 1, it will go for the next element. P plus 1 is locating your pointer is moving to the next element. The next element is 20. So it is displaying that value 20. Then plus 2 is next to next element. P is actually pointing the first element, but we are adding plus 2. Then it will add 2 element address. It's moving to 2 address. And then we are getting the data. So the next element, A of 2. So this is we are having now the index. So this is actually this is equal to P plus 0 star. This is equal to star P. Right? Then P plus 1 star. Next element. P plus 2 star is next element. Right? So this is for this is 10. This is 10. This is 20. This is 30. Right? And also we can use the increment and decrement operator to move your pointer. So that one is here we can operate on a pointer is here p plus plus is we are having post increment, right? So we are what address is showing now the p is moving to the next element. So p is increment by that one is moving to next, right? Here the p is not moving, but we are adding one is equal to moving to the next element. Adding 2 is moving to next element. The P is showing only the first element. Then P plus 1 is we are moving to next element. P plus 2 is moving to next element. Right. Here P plus plus plus. Now the pointer in the P location itself, we are incrementing that next location, right? So this is if you are showing now that on some 0h something 56, now we are making the plus 1, then it is 4 byte, then 56 plus 4, the 5a is there in next address. So 5a is, this is 56 is changing now as 5a because of this increment. So it is increment one integer element. One integer is 4 byte. So it is adding that 4 and it will have that value is now 0x some value at the end we are having 5a. Instead of that 56 we are adding 4. This is 5a. It's a hexadecimal. 5a. 50 plus 4, 56 plus 4, 6 plus 4, 10. Then in the hexadecimal we are having 5a. So 0, 6, 0x, some value 0x, 56, right? Next, p minus minus, then we are decrementing 4 and come back to the pointer, come back to the previous element, right? P plus n is here we are having now, p plus n is just p is as it is, we are having n element is moving now, then the overall is it moved, but the pointer data is not changed, just we are adding the dn. Here we are not, suppose we will have that one p equal to p plus n. Now we are adding that n element and we are storing, we are updating that p, right? It won't, here if you are giving that p plus n, it won't give the update of that p. P plus n star means then it will go for a of, if p is ampersand a is a memory location, then a of n is we are accessing through that one. Similarly, PNS here, we are having the pointer is on location, then go back to one n element, then you are subtracting that minus, then we are getting now this particular element, but the pointer data is not updating. Right here. So this is array, the three-dimensional array, 5 plus 10, 5, 10, 15. So we are having now A of 0, A of 1, A of 2. And then we are having P is now currently we are having assigned to, here you don't give that ampersand, the array name itself address of first element. So this is equivalent to int star p equal to ampersand of a array of 0. So this is the meaning, right? So that one here no need to put that ampersand because the name itself address of the first element. So directly you can write that one int star p equal to arr, right? Then we are incrementing that, we are adding plus 1 and getting the data. So that is p is locating that arr 0, and then we are adding plus 1. Now it will get now the next element. So this is 5, then 10 and 15. So here adding plus 1, it is showing now this element. This is we are printing now, right? Then arr plus I, right? So array is a array is a array itself is a pointer. Then we are adding that index and put now that star, then it will go for the moving to the next element, right? So arr of 3 equal to arr plus 3, 3 plus 2, only that two element, right? Arr plus 2 star is the last element, that 15. It is showing now the value 15. ARR 2. So that is I, right? So I see I can change now 0, 1, 2, and we can access the element 5, 10, and 15. Next one, pointer to pointer, double pointer. This is another one concept of the pointer is double pointer. So here we can have now, this is P is one pointer, Q is another pointer, then this is having the address of another pointer. This is having that address of x. So this is called pointer to pointer. So this is the variable. Then that address is going to store now. Now the pointer address is going to store now. So that is called double pointer. How do you declare the double pointer? Is int star star q. Now it is storing the address of another pointer, then that pointer is locating another element. So here now, this is a single pointer, this is a double pointer. In the double pointer, we are storing address of the P. So this is the link, right? So this is the link now here. Okay, now the star star Q is, if you are having now we are using double star q, then q will go to the address of p, then from that address we are getting now, so this double pointer is address of addresser. So we are going to have now that value 5. So it is getting now from q, it will go for the p, and from that p it will go for, so that 5 is we are getting now. Next one, actually function we are not yet studying, but you simply think about that one, right? So here we are writing a function as this is return type followed by function name. Here we are having now the argument passing. This is arguments, right? Now here that argument. Now here we can call that function through another program as change, then followed by we are having now that one as change passing that x, right? Then here we are having now that x is 10, but it won't change that value of x in the other end. Next one as here we are having passing by reference. What do you mean by that one? As passing by references, we are going using the pointer, then we are passing. Now it will change that value x. The value x on the main program also. If you are calling, we are using this function. If you are using this function, here you have to send the address. Address of x. So suppose here x is 45. Right? So index is 45. Now we are calling the function is change ampersand x. The ampersand x is here using the pointer. The pointer is accessing that 45. Now we are changing that value is 10. So the 45 is changing now as 10. Right? If you are calling this function, it will change within the function, but this value is not affect the variable while calling the function. From the called function, it won't change that value. So this is call by value. This is right call by reference. So we are calling the function by reference. So this is we are having now the pass by reference. Right now we are calling the function is change ampersand of a. So the ampersand of a is, so this is ampersand of a is address. So the address is going to, so p equal to ampersand a. So it will affect the 5, right? Now it will execute that 5, 10, changing that value a equal to 10. Then we are getting the output is 10 now. Modifying the variable inside the function. So inside the function, we can modify the external variable. Next, then another one concept called structure, right? The structure is we are having now a container where we are having now two element with different heterogeneous data type. Heterogeneous data type means this is integer, this is character. So we are having now this one as actually we are having defining a structure. So it won't create any variable. If you want to create one variable, then you have to use structure student with S1. S1 is a variable where we are storing two elements. One element for ID, then another element is the name. This is the case, right? And we can use the pointer, right? So just we are declaring a pointer of type struct stored, right? So that is it will hold a structure. So in the structure, we are having one ID and we are having a name. So this is the total block of one record. That record is of type student, right? Now here we are giving the address of S1. So the S1 is the total block address. So address of S1 is assigned to P. Now using P, we can access first element and second element, right? So P, then you are accessing that using pointers, you have to use the arrow. Arrow is the operator. Then you have to give now the field name. P arrow ID is accessing the first field. then p arrow name is accessing the next field. If you are using the pointer, we have to use arrow, right? If you are using that variable, right? So here student S1, then here S1, through S1 you can access the ID is S1 dot ID. Dot operator is used for accessing the field of the structure. Then S1 dot name. If you are declaring that with variable, if you are declaring with the pointer, then using a pointer we can access, we can use the arrow mark. The arrow mark is used now, right? So this is here. We are having a pointer, then arrow mark is the integer type, and this is a string type. Then we are having now the, so we are displaying the content of 101 and Ravi here, right? So here we are getting now the access using the hyphen and greater than symbol. So this is represented as arrow, right? Hyphen the followed by we are having greater than symbol, two character. Two character without blank space, right? Just direct in immediately you got right. So this is represent the arrow. This is accessing through pointer of the record field, right? Then we can using the pointer, we can have now that we have to declare, we can declare that variable dynamically through the function called call alloc, right? C alloc. CLOC. So that one is here. CLOC with the size of that memory, right? So here, if you are going n into size of int, so integer size with n is 10. So we are having now a block of memory at the 10 byte, and 10 byte is going to 10 byte, 10 into 4, 40 bytes. Each 4 bytes are used for one integer. So 10 elements are allocated, right? Then we can reallocate is giving now the, we can change the size, right? So here we are having CLOC with we are using the pointer, we can access that one. Then the pointer can move each and every element, right? Now you want to change the size, then you have to use realloc with the, instead of 10 we want to have that extent 15, then size of the int, then it will have now allocate that one to another 5 elements, realloc. Then if you are dynamically allocate a memory, then we have to make free of that after using that your variable, and you have to make the free with the pointer. Then whatever that allocation, the allocation is going to make deallocate, and it will release that memory for further use, right? Here we are allocating a memory, right? So that is, here we are allocating 5 integer, we are allocating 5 integer of size integer, and then we have to make it as a integer type pointer. Then we have to allocate p. Then you can use that one with p of i. P of i is the first I is 0, so first element, the next element 1 and 2 and so on, right? So I is changing now that one. Then we are getting now in that location, 5 location. So it will allocate the 5 location, and we are having a first pointer, and then by the program, so I equal to 0, I less than 5, 0, right? So P of 0, we are assigning that one I plus 1, so 1. The location 1, we are having that value 2. Then location 2, we are having value 3. Location 3, we are having value 4. Location 4, we are having that value 5. Then after that, then we are making the free of D, then it will clear all memory. It will clear all memory. Next, so if you want to have a pointer with for holding any type of data, then you have to declare that variable pointer variable with void. Then we are using that if you are using this one as PTA address of that A, then the pointer is having integer type. then we have to do the typecasting. So typecasting we have to make it as, so typecasting you have to make it as star integer star p, right? Then only it will have, now the pointer is void pointer, and then we are storing now that integer. Then we have to integer address of that integer, then it will locate that a. Now you have to mention about that type integer, then only it will take 4 bytes, right? If you are using the floating point type, then it will go for that floating point type and we can store it now. Then we have to make it as a float, then only it will take 8 bytes. Like you have to change the size according to what type of data in the pointer pointing, then you have to use the corresponding data type. That one is very important here in the case of void pointer, right? The common pointer mistake is using initialized pointer cause undefined behavior. Uninitialized pointer, right? So uninitialized pointer is behaving, right? If you are having integer star p, now if you are printing now, right? So print up percentage d with star p, it will give some random value. So you have to be careful with that one. So if you are making this one as null, right? So pointer is assigned to null, then it will give no empty value. So tangling pointers, pointer pointing to freed memory, right? So if you are making free of that p, after that if you are using now, then it won't show any location. So it will have the random value. Memory leak means actually here we have to make free that allocated memory. If you are not using, the memory is allocated but we are not deallocate, then that memory is going to waste now, right? So wrong dereference. So we are dereference is free with the pointer p. With if you are changing that one, then it won't make free that corresponding location. So dereferencing invalid address. So invalid address dereference பண்ணக்கூடாது is not required, right? So that is here, right? Then this is one simple program. Here a is 10, p equal to 20, both are integer type. Then we are having that p1 is pointing a, p2 is pointing b, right? So that is here a is 10 and b is 20, and then we are having p1 is placing that ampersand a, address of that a, p2 is placing the address of b, p2 is placing the address of b, right? Then here we are having now before swap, right? So we are having now a percentage d and p percent, a equal to 10, p equal to 20. Now you are swapping now using pointer, right? So we are swapping now. So that one is here we are using the temporary variable, and we are assigning now that p1 star p1 to term 10 to term, and then we are making that 20 to 10. So the 20 is going to come here, and then we are having now the term equal to p2, so 10 is going to back. So we are exchanging these two value by using the pointer, right? This is not required now, right? So that one is enough for your case, right? After defining the function only, you can understand now, right? So we can stop here, then we will continue by another lecture.